There we go. I had it way too cranked up in the headset. I was probably repeating.
Hey all, just getting stuff started up. What a day. I guess I will switch to the camera here since we're a few minutes early, getting things rolling. Waiting for a couple of people to pop in. We'll see what we can get. I will see if I can get, I think Kat's busy doing Merch Minion stuff today, so I don't think we'll have that. But let me grab the iPad so that way I can talk to you guys while I build. Give me 2 seconds here. I will add that to the plethora of screens. And we'll see what we can do here. All right. Pull up Twitch. Get over to the dashboard so I can see people chat. Then we'll get rolling on the build here. Plug in the power. So who's in the channel so far? We got what? 5? Welcome to the channel and all of that stuff. So I guess next thing we do is I will start. Stream quality seems kind of dodgy today. Nice. Welcome back, 713. Good to see you. You're always here. That's why I love you. Stream quality seems to be kind of shit tonight, and I don't know why. Give me just a second. I'm going to bump the bitrate down just a smidge, and I will be right back. I don't know if you can do that live, so I'm going to go down to there. I don't know if you can do that live. If it doesn't fix the issue, I will restart the stream real quick. We'll see what I can come up with. Usually a lot of motion will show the problem. That seems to be a little better, down around 6,000 instead of 8,000. Hi, Bjorn. Look, the Barking Pony has joined us. Welcome back, Barking Pony. All right, let's see here. All right. One of these is the right size. There we go. So these have one flat on them, and they have 2 set screws on them. So I'm just going to line one set screw up with the flat and the other one just to add a little extra stiffness. And I don't know exactly how high these are going to be, so we'll have to adjust them. So I'm just going to get them snug so they don't come loose until we're ready to go on the next ones. Six viewers, slowly climbing. So I think today what I'm going to try and do is get the belts on and everything lined up in this upper section, since this should all be relatively rigid. So one of the first things I need to do is take these really long 16 millimeter threads and go in. See if I can get a picture of this. And go in from there we go. So I'm going to go in from, normally these go in from the opposite side. So the tension blocks for the belts are these here, and they go in this way, and they grab the belt, and as you tighten them, they take up some slack in the belt. Well, you put the screw through this way, and then it goes into the block that way. But when you sink the brass inserts into this piece here, it kind of melts a little of that plastic and it bunches up. So by running a screw in from the opposite direction first, which happens to line up with this, so probably ought to do that before you put that in if you were going to be smart, but I never claimed to be, so is what it is. So just put this in from the brass side first and use it. You can feel how it binds up right there. So I'm just going to continue to run this in and kind of punch through that plastic and push that little blob out, so that way this will go in easy from the other direction. It would be easier if I had this on the drill, because then I could just run it in and out, but basically you just run it in until the threads come out the other side. And the reason they put these brass pieces on the far side is because it's way stronger in compression than it would be in tension. They would have a habit of pulling out. So by putting them in from this direction, they don't pull out. So those threads go all the way through. And there are longer bolts in this bag that I will probably go get specifically for that. And I'm also going to do this, because I'm getting tired of turning that thing already, and I got 4 more to do. So that is a 2 millimeter. So go in here, grab the 2 millimeter driver and the extension. Chuck that up in the drill, just for ease of, and when I go to do that, I'll mute the mic so it's not so doggone loud. Let's see here. Hey, we're up to 10 viewers. Appreciate it. Thanks for the views. Hey, Trolling for Dollars, welcome back. Good to see you, man. Let's see. All right, so I need, there are a couple of really long, here they are. So these are by 45, M3 by 45 cap heads, and they're specifically for this particular place. So I'm gonna pull out these 16s and run the 45s in. Is that too loud, or do you guys want me to mute the mic? I don't mind doing either one. I am totally okay doing that if you guys would rather me do that.
You streaming?
I am streaming. Thirties. I think Kat's gonna jump in and chat with us while we do that. It would seem so. That's funny. We're up to 10 viewers. We're doing good. I know Jerry's streaming tonight as well, so maybe we'll get lucky and pick up. Maybe we'll get lucky and pick up a raid from Jerry on his way out when he's done. That would be super cool. All right, I'm going to mute the mic for just a second, and I'm going to run these screws in and out a little faster than I can do by hand. So. Well, that didn't go according to plan. Now I got to figure out how to fix it. So these ran in, and when it got to the bottom, because I was not looking, I ran it too deep. I think I pulled the threads out of the brass. So now I got to figure out how to fix it. I'm going to take this. I'm going to take this off so that I don't have to worry about it hurting it or scratching it or whatever. I can add it back on later. Then I can get straight into this. Okay, I did not pull the threads out of the brass. The driver is crap. Those cheap bits are garbage. And it rounded the tips on the driver, I think. Yeah, it didn't hurt the threads on the brass. That's a reassuring thing. It felt like it did, but it was just the crappy driver tip. So, same thing again. Mute the mic real quick. So to answer your question, I went to the ZLT because the ZL that was built on the previous stream is not mine. It went to Kevlar Condom on Twitter. Good evening. How are you, man? Good to see you. The what do you call it? I can't even think. Basically, long story short, Adam got to keep that one, and I wanted one also, so here we are building another one. We actually bought both of them at the same time. The ZLT kit just wasn't ready, so I built Adam's first. And once the ZLT kit was out and got here, that's when I started building this one. We bought both of them up front, though. I'm going to do the same thing, pull this mount off because it makes getting to those holes much easier for the belts. Just remember, be careful with these because you can cross thread these real easy. So putting them on and taking them off, just be extremely careful with it. Yeah, no, don't feel sorry for asking questions. I mean, that's why I'm here and why I'm streaming it. So I built the like I said, I built the ZLT for Adam. He didn't want or need the extra vertical, and I figured why build two of the exact same ones, but when we can build one of each. So that's why we ended up doing that. All right, now that that silliness is complete, hopefully I won't have to do that again. Yeah, see those fit through, and you can feel on the other side that they go through all the way and don't get in the way. So you can actually, I can show it. If you go in through the hole on this side, and it comes all the way through, you can see that it now extends. It's kind of hard to see, but you can see that this extends through, so it's got a clear line through the plastic now. So that should eliminate that as an issue. So now I can put the two idlers back and front, or Yeah, front, I believe, is toothed up. Hey, we're up to 14 viewers. That's awesome. Let's see here. I am just grabbing the. I've got the document up on this other screen. So, yes, it looks like front is toothed up. Yep, front is the tooth gear up. So. Same thing, wait, roll it backwards till you feel it tick, and then thread it in. Be really careful not to crush that bushing. Once you get it snug, make sure everything rolls smooth, good to go. A lot of reflections on that stuff, but that's all right. Shiny aluminum and all. I've got a needle. I'm going to use that to nudge this bushing into the center, and then it should thread down without catching. Perfect. Let's give this a snug. That should take care of that. Need to come up with a better solution for this cord. It's always in the way. Okay, next. Zoom out a little bit. All right, now we need to get some belt, I suppose. Dude, just come on over. We'll build it. We can do. If we're not live streaming it, we can build it in one day, no problem. I'd love to help you build one of these. What I need is somebody in the Seattle area who wants one but doesn't want to build it, that will buy it and let me have it for a while. I'll put it together. I'll make sure it's right, but I'll make YouTube videos out of each step and post those on YouTube as a tutorial. I'd love if anybody in the Seattle area wants one of these, but doesn't want to go through the process of building it and doesn't want to pay for a pre-built shipped from R3D. Talk to Joe, tell him that I'm going to build it for you and build a tutorial videos out of it. It's going to take a while because that process is, record each step, edit each step, upload each step. So it'd take little while for that to happen. But if anybody's interested in that offer, definitely hit me up. I'm on Twitter, Joe, here, whatever. And we'll make that happen for somebody. Because I told everybody I'd live stream the ZLT, and then as that was getting close, I thought about the fact that it would be nice to have tutorial videos for all these steps and just go step by step through the instructions for this. And but I don't have another printer to print, so kind of ran out of options. Got to get the last belt holder wherever it went. Somewhere in this pile is another belt holder. I hope. Oh, there it is. Okay, perfect. Not short. The ultralight Y holder is not. I bought those extra. Dude, I'm going to be building so many mods for this thing. It's like, this is just the beginning. This is just the assembly with mostly stock parts, except the bed and some of the Y mounts. But I'm going to be building a bunch of custom stuff for this thing. But yeah, man, if you want to order a kit, I will be more than happy to help you build it. All right, let's see here. Bed preparation, cooling fan, aligning the belts. Got to do the attaching the belts part. 3x45s. So we need 3x45s. The only issue with all of the add-on parts is the amount of gain you get for a lot of them is diminishing returns. So the kit comes with all of the stuff that gives you the main benefits without, I don't want to say wasting money, because it's not wasting money. It's without spending money for minimal improvement other than aesthetics and because you can. So that's kind of where things seem to fall at the moment. Bondtech for sure, like no question asked. Bondtech. It's just, you know, I'm gonna draw a line in the sand. It's just a better extruder. The Titans are good, but these are better. Too much. Chasing these holes is a bit of a pain sometimes because you get little bits of plastic that are in the way. But no big deal. There we go. So once you can see through the hole clearly, you're good to put it in. I just had a little bit of a burr left that was making getting that in there a pain. There we go. Threads are started and it adjusts. So perfect. So now this one, I always mess up the belt paths here. Just got to scroll down to the belt paths real quick. Upper belt path. Okay, so we flip this around so that I don't have to think backwards. And then it is around this idler, around that stepper, around this idler, around this idler, and then I'm going to loosen these motor mounts so that the stepper can be all the way closest to the machine body. So that way I have as much room as I can get to, what do you call it, to be able to work with the belt. And then I need a pair of nippers. So then you just pull this snug, and then there's quite a bit of extra belt in the kit. So I'm just going to nip it like right here. Then I'm going to use Sharpie to mark roughly where the belt clip will go. And then you won't be able to see this on camera. Basically, I stretched it. And so basically, I just stretched it to fit here. Nice. Doesn't have to be crazy tight, just snug. And I'm going to switch to the other camera real quick. So I stretched it to here, and I just put a little mark here and here, just to where the belt clip's going to go, because it folds. The belt folds back behind the belt clip. So now that I've got that, we know that the hole in the belt clip goes towards this side. So, and you can also tell because of the teeth. So I'm going to line that belt clip up with basically where I marked it, and then fold it back on itself. And hole looks clear, so I should be able to get the threaded bolt in. Now it's all falling off all the idlers, but that's okay. Okay, so over those idlers, come on, get on there. Over that idler, over this idler. Now I should be able to just push this in, get it close. Now we're already tight, or not tight, but we already have some snugness on the belt, so it shouldn't fall off the idlers. Gonna grab one of the 45s, wherever I set those down. There they are. And should be able to, this is going to be a little harder because it's on the inside of the belt. So just going to kind of, oh, I also use a washer on these because it distributes some of the load and reduces the torque. Yay, no more extra holes. Now send me a pair. Sorry, I'm having a little trouble keeping up with chat. Let's see here. I hate extra holes. To the point where I have thought about tapping those holes and putting little cut short handmade bolts in those holes just to fill them with, or taking a little bit of like a dab of super glue and just cutting some M3s short and just literally super gluing them in the holes to cover up the holes. Hope Hopefully this starts easy. There we go, good. Okay, so that one started much easier. It didn't have the little burr that was in the way. So I'm not really going to tighten it down real tight, but now if we roll this, if we roll this back motor, we get our one direction of travel. Kat was nice enough to bring me snacks, but I'm going to wait until after the live stream.
You should at least come over and take a bite or two before you make yourself sick for not eating all day.
No, I'm fine.
Okay.
Yes, Mom.
Weirdo.
Maybe. Okay, definitely. All right, same thing in the reverse pattern. What's up, Steve? Welcome back. Yeah, but see, if I put M4s in, they won't be the same size bolt head, and that will also bug me. So what I'll probably have to do is tap it to something bigger, put Healy coils in it, just to get M3s in it. That's right. Don't make me turn this stream around. That sounds like something she would say. All right, same thing. We're just going to push this belt clip in, get it close. But if they're printed, they won't match either. They've got to be the same. All right, hopefully this one will start simple just like the others did. Not as simple, of course. And of course, I'm trying to do this without nicking the rails or anything. All right, there we go. That's into the threads just slightly. -4, screw that. All right, so that one goes there, goes around this stepper here. I'm just going to turn the printer because it's easier that way. Around that idler there. Going to have to feed it through this idler because it's on the inside edge. $40, huh? I will have to get out my guitar tuner and make sure that's right. I wonder if that resonance has anything to do with the print speed. Okay, so riddle me this. This is something I don't know. You guys might be able to help me on. Do you really use a guitar tuner for it? That's kind of funny, because I thought I was being a smartass. All right, same thing. Gonna see if I can make it so you can see this. Spin this around. All right, so pull it snug, give it just a little bit of a line at the beginning, and then in just a little bit where you're going to kind of make that, where you're going to set that clip. and figure out where you set the clip, because derp. Because when you set it down and then it's gone. All right, I just had it. I didn't need that printed part. That other belt's not tight. Here, look, there's tons of play in it. This one too. Here, look. All right, now I gotta find where the hell I set the other belt clip. Damn it, Pa, where'd you put the other belt clip? Because I just had it. Oh yeah, it's terrible, I'm sure, right now, but we'll fix that. Doggone it. Didn't put it in my pocket. No. Knock it on the floor. I don't see it on the floor. It's not under the printer. All right, I lost it, guys. Where is it? I don't like you anymore, Steve. So, I can't remember. I think I have the mount for the BL Touch. So I think I'm going to put a BL Touch on it out of the gate. If I can find the other belt clip and we can continue with the build, that would be nice. Where did I set it down? There it is, right in front of me the whole damn time. Note to self, don't set little black things on top of black surfaces. They're hard to find. All right. Belt clip. Roughly right there. And then clip this right there. So they give you lots of extra belt, so you can not be as miserly with your belt as I am. I have a piece about this long off the other one too. So no big deal. All right. So throw that in. There we go. Oh, by the way, for word of warning for those with beards, belt plus beard plus gear, bad news. I on more than one occasion have lost whiskers to belts and gears, or belts and drive pulleys. All right. Okay, so here's a question. Are you measuring the hertz for the belt tightness off of the front or off of this side right here? Are you measuring it off of this side right here? Because this is the only, like, I guess that and this the longer length here on this side. Okay, the long return belt, this one. Yeah, okay. Yeah, the front, the one between the furthest out idler and the, okay, so then we are, here, let's see if I can get this. Here's what we're at now. Floppy. Also floppy. So we're not tight enough to matter. Doesn't have to be tight enough to matter right now. I don't want to pull everything tight and get everything all angry at me yet. So next step. That is definitely not level. So let's loosen this up and slide that down. Get the calipers out. And so that is left right about 14.85 off the rail. So move that down. Okay, I'm going to have to flip this gear over to get it low enough. I think that's a common thing, and I think it's even in the instructions. Yep. So at this point, I'm kind of building a little bit of this off memory from the last build, so sorry if I'm not dead nuts on the instructions here. All right, belt at the bottom of that gear, or pulley, is pretty damn close to 15 millimeters off the rail. Belt, a little lower.
Incoming.
The
Did you hear me?
yes. All right, so roll that just a little bit. All right. Tighten that down, tighten this down. Holy shit, Barnacles, dude! What are you doing, man? Good to see you. Thank you for the raid. I appreciate it. Lots of new people, apparently. So I'm in the process of building this 3D printer. This is the Railcore ZLT. It's 300 millimeters by 300 millimeters by 600 millimeters tall build volume. We are on probably what, hour 20, 25, and of the build process. It's a lot slower when you're streaming, so you can build this printer in about 15 hours if you're just following the instructions and don't have any major interruptions. But let's see here. I don't have to cuss a lot to hold their attention. I'm just that awesome, dude. No, that's a joke. I'm not that awesome. So this is in theory, the first ZLT kit, and definitely the first ZLT kit to get streamed being built. Talk to you later, Jerry. Thanks for the raid. I appreciate it. You're awesome. So that is super, super cool. Holy crap, 216 viewers. I am just floored. I appreciate you guys coming in and hanging out with Jerry. It's fun hanging out with Jerry and modding his channel and stuff like that. And he kind of inspired me to do this Twitch thing. So still kind of learning and figuring it all out. Hopefully the cameras and stuff are helpful with all of that. Let's see here. Holy cow, 50 bits. Thanks, dude. Appreciate it. So I'm going to have to spend a couple of minutes and address people in chat and things like that. So questions, thoughts, what do you guys want to know, since there's a lot of new people in here? I'm more than happy to kind of share the knowledge and see what you guys want to know. I can do that. I can definitely raid auxiliary when I'm done.
Oh man, they beat me to it. I was just coming up here to tell you that.
So this printer is 300 millimeters wide by 300 millimeters wide by 650 millimeters tall. And that's the build volume, not the actual size of the printer. The printer's larger than that. A couple things of note about this printer is it's using linear rails instead of, okay, so quick impromptu tour here. I'm going to switch cameras. No, I'm good. So down here this is a CR10. And so that's a Great Dane, or at least a Great Dane butt. So the CR10 uses these extrusions here and here to ride on for its rails, and it uses them here and here for the other direction. And this is the Great Dane again.
He's helping.
This printer uses, sorry about the shaky camera. This printer here uses these rails. And these rails are actually machining equipment parts. So they're super high precision. They're called linear rails. They have a bunch of bearings that work kind of like a caterpillar track or a tank track that run along this precision machined piece, whereas some of the less expensive printers are rubber wheel on extrusion. So it gives you a lot more stability. The other thing that this printer does specifically, and none of the other printers do, is it's got 3 Z screws. So I'm gonna grab one real quick. One Z screw goes in at each rail, and by independently controlling all 3 Z screws, it can actually physically level the bed. Zoom out here so you guys can see better. The other out. So these lead screws right here, there's 1 here and 2 on this side, so it's like a triangle. And as you adjust them independently, the machine will calculate, it'll measure and calculate how much it needs to adjust the bed, and then it adjusts the bed to be completely flat. That's the big thing this printer does that none of the other printers are doing. Even the $5,000 professionally made printers aren't doing this. I've got over here in the corner, I've got an Ultimaker 3 and it also doesn't do that. This is kind of the only guy doing it. So this printer is all about overbuilt and overkill. It's a really neat machine. Hey, thanks for the tip, man. Appreciate that. You probably can, especially if you use flexible filament. I would highly recommend flexible filament, or else it would chafe really bad. I mean, unless that's your thing, which I won't judge. All right, so belts. So what I'm doing now is I just ran all of the belts for this upper section, and this is what they call a Core XY printer. So it doesn't have a motor that directly drives the X and Y axis. I'm going to move this so we can kind of see a little bit better. So this is the print head, and it moves this way, and then the whole rail moves this way. So the unique thing about Core XY is it has two drive motors, one here and one here, and it's they're not directly related to X and Y. So if you turn one, it moves on a diagonal, and then if you turn the other, it moves in the other diagonal. So if you want X and Y, you have to turn them both one way or the other way. So if they both turn clockwise, you get one direction, and if they turn opposite directions from each other, you get the other direction. So that's how it does the XY movement. Yes, it uses Duet boards. Yeah, Duet, and then the Duet Duet 5. So the Duet 5, I actually have those both here. So this is the Duet 5 board, and I'll open that up real quick so you guys can take a look at it. So that's the Duet 5 board, and then I'll take the Duet board out for you real quick. So this is the Duet board, and I'll bring it a little closer so everybody can see it. So this is a combination of power inputs, Wi-Fi receiver, USB card reader, USB port, some control inputs and outputs. This is for like motor end stops and things like that. So like when it touches a button, it knows to stop driving the motor one way or another. It has some thermal sensors on it that you can plug thermistors into. It's fused. It can drive all kinds of stuff. It's very versatile. But when you pair it with this board, with that large cable, it enables you to have a ton more inputs and outputs. So they use these two to enable you to have those 3 independent Z steppers, so that way you can drive each corner of the bed independently. It also gives you a ton more inputs and outputs, so you can do things like custom LED lighting and all kinds of other fun features that are added later. I'll put those back in the ESDs. So, fun fact, Steve here in chat is one of the developers of this printer, and he is good at answering all kinds of questions I make sound stupid. So yeah, the E3D tool changer, the developers of this, Tony and Steve here in chat, are working on the E3D tool changer, so you can have multiple print heads, things like that all at once on the printer. We don't know exactly what that's going to look like because the beta test kit for that just came out, and they just got that in-house to start working on that. But this whole printer is open source. All of the files and stuff are on Google Docs. You don't have to buy this kit from anybody. You can go to the bill of materials and source all of the parts yourself. They have links to almost everything where you can buy it on places like Amazon and things like that. So you can source all of this yourself. This happens to be a kit from R3D where they source all the parts and they bring it all. It shows up in one box. It's a lot more time efficient for somebody like myself that's busy, that I can just pick up all the parts and go with it, which is why I'm building this kit. Stream looks reasonably healthy. Is it still going for anybody? Is it cut for anybody else? Yeah, stream looks okay. Okay, good. I thought so. I just wasn't sure. Wanted to make sure it wasn't something on my end. Okay, good. So what I'm doing right now is I already aligned the belt on that side. So it's really critical the belts are all parallel. So what I'm doing here is I'm measuring the distance between So right now I'm adjusting this upper belt. So I'm going to measure the distance between this belt and this extrusion that it has to be square to. So put that there, and it doesn't have to be quite perfect. So it got to be really close. So that's 25.2 millimeters. So now I'm going to go over here and I'm going to match that 25.2 millimeters on this drive. Got to loosen it a little bit. Other size. So get 25.2 millimeters right here. So we got to go up just a smidge. And the closer you make it, the more accurate your printer is. So taking your time on these steps is really a good thing. It makes a huge difference in your total print quality later on. So now that I got that side adjusted, I'm going to go back and I'm going to check it one more time because that's going to lower that side. So now we're at 24.5. So I'm going to measure this side here, and it's also darn close to 24.5. All right, that's close. Within 0.1 is probably more than close enough, but the closer you can get it, the better. So snug that up, snug this up, and I haven't done any of the belt tightening yet. So these belts are still very loose. So you'll notice they've got a lot of play in them. And the old school of thought was apparently, and I learned this today, the old school of thought was 60 hertz. So when you flick this, it should vibrate at 60 times a second. Apparently it's looking more like 38 or 40, 36 to 40 is more appropriate. So you can use something like a guitar tuning app on your phone, anything like that. We'll do that. Let's see here. Some of the other cool things for this printer. I have this, which is the Duet touchscreen panel. So that'll be going on here, which can control the Duet. It'll go, I haven't figured out exactly where I'm going to mount it yet, but it'll give you touch screen control over the Duet on the unit. The slicer profiles are coming along pretty nice. There's a Google Docs repository of all of those, and so far I haven't really had any trouble. If you've got a little bit of experience doing profile stuff, you shouldn't really have too much trouble. It's pretty standard Core XY. Just you gotta have to set up your boundaries and stuff because you're gonna have to tell it how much X, how much Y, how much Z, and then they're all going to be slightly different, but they're already kind of generated. Then you'll kind of fine tune it for your own filament because each filament's a little different. Your own print conditions because that's going to make a difference. All right, so there's that. So, all right, Steve, what do you think we should do next? While we got a little bit of time. Yes, firmware is open source. The motors are on. I guess we can get them pulled tight and see about getting that that magic. It's one of these. Oh, yeah. I don't know if you guys will be able to hear this or not, but so it'll have a very distinct tone, and you want to get that right around 36 to 40 hertz. I don't know how audible that was. All right, so then I'm gonna run this down a little bit, and then run this down. Yeah, it's a pretty low frequency, so it's going to be, so 60 hertz is the same sound you get if you can hear like the buzz from electricity. It's going to be a very similar. And if you'll notice, before I tighten this side, it's going to sound very different. And then you pull this drive motor a little bit out. Nope. 3 options, guessed wrong twice. So snug that up, snug this up, and then should get it fairly close. So that's still a little bit looser than the other one. So we're gonna go just a little tighter. Once we get it close, we can fine tune it with the threads that are on the center print head. That's really close. So those two are close enough that I should be able to get the difference that I need out of the threads on the center of the print head.
Yes, it is.
And at that point, that should be good. So the really important thing about the way this works is getting those two belts the same tightness keeps this rail from being twisted because of the different torque each belt exerts on it. So it's got to be pulling exactly straight. If this one's a little tighter, it's going to pull straight because it's going around this 80-degree corner, but it's also going to pull forward harder than this one pulls forward, than its opposing side pulls forward. So it'll cause it to shift and be crooked, which will cause jamming of the linear slides. So you got to be really careful with that. Yeah, I was going to fine tune that once, because I don't have side panels yet. I was going to fine tune all of that at the end. Because I don't have the front and rear panels yet. All right, so we need to move these slides slightly because right now they are in the wrong spot. These are really nice printers. Yeah, dude, just when you order it and you get it and bring it on over and we'll build it. We can easily do it on a 1 day if we do a long day. Okay, so on the bottom right here, and I don't think you can see it on this camera very well. So I'm just going to point it kind of down and hopefully you guys get some view. I'm going to slide this out of the way here. There we go. That should give you at least some view. Most of the view you're going to get from the main camera. Wow, we still got 71 people in here. I appreciate you guys coming in and hanging out. I do this stuff all the time. Always working on 3D printers or batteries or electronics or any number of various projects. Just before the stream started, I had a couple of LEDs in the overhead light were out, so I took that all apart and I changed those and adjusted that. Actually kind of had to bodge. So I didn't have the exact LEDs, so I had to make them a couple of modifications to get it back up and running. We got it all back up and running. Built a custom cable to power the lights that are on the ceiling and all that. So always some sort of interesting project going on around here. I appreciate you guys throwing me some follows and stuff. That's awesome. Just unbelievable. I really, really appreciate you guys coming in and hanging out with me, watching me build strange things. So what I'm going to do is these vertical slides, the Z-axis slides, the brackets that hold them are mounted to this lower rail. It uses four bolts at the top and 4 bolts at the bottom. I'm going to loosen those so that I can slide this whole vertical rail. So loosen those 4, loosen these 4. Come on, one more. No, I'm sorry, 3 bolts on the top and the bottom. So now that should be loose enough to slide. And then I can mount the stepper motor. So there are 3 different types of stepper motors in this build. These 3, because there's 3 Z-axis, they're all the same. They're 1.8 degrees of rotation per step. So every single time it ticks, it's turning 1.8 degrees of rotation. The steppers that are up here that drive the X and Y, they're 0.9 degrees per step. And that gives more precision up here, but not as much down on the Z. And that's made up for by the number of threads on these Z-axis rods, these lead screws. So they are what they call single start. So that means it's 1 spiral of threads all the way down. But if they were, dual start or triple start, I believe they make up to 4 start, where it would be 4 independent spirals. when you have more starts, it travels faster. So by having a very low number of starts, you have to turn this more times to get vertical, which makes up for the fact that these are 1.8 degrees per step. So for example, if you replaced these 1.8s with 0.9s, you could go to a 2-start rod, and that 2-start rod would make up the difference, and it would be exactly the same. Okay, so so Steve just said the z-axis adjusts 0.01 millimeter per full step of a stepper. These steppers can do micro stepping, so tiny fractions of a full step. So you can get absolutely ridiculous resolutions with this printer. Most printers will print, a lot of printers print reliably at 0.1 or 0.2 millimeter layer height. Yeah, so 1,600 steps. It has to turn what it considers 1,600 steps per millimeter of travel. So you have 1,600 independent locations within 1 millimeter of height. So we need these 50s. And I believe the way this works is that one of these. So this is the coupling that they use to join the Z-rod to the stepper motor. And then these are bearing blocks. No, because resin printers are good for other things. This printer will print 0.02 really reliably, and Tony has his printing 0.01 millimeter layers consistently. That's 10 times thinner than a typical printer will even be happy printing. My Ultimaker 3 will print, I can consistently get like 0.8 millimeter layer heights. Or I'm sorry, 0.08. Yeah, wait, 0.08? Yeah, no, 0.8. Anyway, can't think. This printer will can consistently print 10 times thinner than most printers are capable of doing consistently. Steve, fix my brain. Thank you. Yeah, 0.8 is what my Ultimaker will do, or 0.08 is what my Ultimaker will do. This will do 0.002. So basically an order of magnitude more accurate on the Z. So these are directional, small hole, big hole, small. The lead screws are large, so these just go on there and then get tightened down. Thank you for fixing my brain. It has been a long day. I spent all day today designing group policies in Active Directory. So that's my day job. I work IT stuff for a living at one of the large universities here in Seattle. One more of those, wherever it went. There it is. All right, so we've got stepper motor that bolts to this plate right here. So it's going to go up through this plate. I have to very carefully lift the printer. Goes up through this plate. and then this bolt goes down through this bearing block. The tall version has this bearing block. The smaller one does not. And it's just to give a little more stability to that Z-axis lead screw. So you just run that down and then through to mount the Z-steppers. These are 3D printed parts. So there is some 3D printer building 3D printers going on, which is a really cool thing. So I'm going to give this a little bit of a gentle persuasion. There we go. If it were only that easy, man. They're good, but they're not quite that good. You could buy a 3D printer, 3D print a bunch of 3D printed parts, then buy a bunch of metal parts, because you're still going to need a bunch of metal parts, and then return it once you're at that point. You could do that, though. At that point, just have 2 3D printers, because that's better. Yeah, you're going to have to find some pretty stout materials if you're going to make a 3D printed hot end. Yeah, I just didn't have anything. Well, I didn't have to tap it very hard, just a little gentle persuasion. I guess I technically could have used a hammer. I need to label this so that it says reset button on the handle here. Yeah, it's great to see you too, dude. I'm really glad you got to come in and see the stream. So, useful little tool. It's just a block of metal that I have drilled a few holes in because it's useful. No, actually, so this is the best thing since sliced bread for screws while you're doing assembly, because you can write on the non-stick coating with Sharpie, and then when you're done, you just wipe it off with alcohol. Just don't drop this because you'll have a really bad day. And then once I'm done, I will migrate them all over to these. So I've got all these inexpensive bins. Walmart had them on sale. And they've got latches and locks, so I'll migrate all the screws over to that. But at this point, I probably have, just bags and bags and bags of screws and nuts and bolts and all kinds of things. Yes, I'll also wash it before cooking muffins. The wife, Gamer Cat Studios, here in the chat is occasionally like, "Where's the muffin tin?" I don't know. I don't know where it went. But don't let her fool you. She likes 3D printing as much as we do, so... All right. Got to make sure that these are set in far enough. Yeah, you're definitely a nerd. Hell, you print for a living, dear. Not 3D printing, but you print for a living. Speaking of printing for a living, down in the thing below, if you want to support this printer, I have had Kat whip up some merch. and all the proceeds go to the guys that are developing this open source printer to help kind of kick back at them if you guys are interested in supporting them at all. I do have a couple of stickers and stuff. So we do Jerry's stickers. I don't know if you guys know this, but we do Jerry's stickers and things like that. So Railcore stickers and some t-shirts and things like that. That bearing block has one 608Z bearing. So it's standard skateboard bearing, open source, inexpensive, readily available. It doesn't really need it, but it's kind of a nice to have. So I'm just getting these all started so that they'll all tighten up evenly. So, where's the bucket? Here. I think I paid $15 for all of these after the fidget spinner craze died off. Exactly. One man's fidget spinner is another man's actually useful thing. You are correct. So that's what that looks like once it's all assembled with the bearing block. Now we just do that 3 more times. We'll put all these bearing blocks together all at once, save us a few minutes. So I always put washers on stuff. It's not called for in the instructions explicitly, but anytime I'm putting bolts into plastic parts, I like to throw washers on things. Since I have piles of them because they are needed in the build in places, I just put them on because if you got it, pull on it, right? If you guys are interested in this kind of stuff, feel free to throw a follow, and it'll let you know when I'm doing this kind of thing. So I'm either hosting Jerry or hosting other channels that do stuff like this, and kind of try and keep. I don't do a whole lot of gaming. I do watch the occasional gaming channel, but mostly nerd stuff, mostly making things or whatever. So we'll just seat all these in the bearing blocks. They go together pretty easy. Then we just got to make a couple of fine-tuning adjustments on where the placements of these Z-rails are. And then we will put in the Z-axis lead screws. And then we can look at mounting things like the bed and stuff like that. So all right, so next I'm going to spin this around and work on this other one from this side. Hopefully Hopefully you guys will be able to see that. Let's see here. A little hard to see, so I apologize. Just loosen these bolts that are holding the Z slide at the top and the bottom. Loose, loose. They're not tight or anything, they're just there from the initial assembly. So I should be able to slide this whole rail. And I believe it is inside and inside. So I need to slide this one closer this way. See, it's got, a little hard to see, but I've got plenty of play. I can move this rail around. Just kind of slide it in so it's out of the way while we do the assembly. So put this stepper motor in. Move the hammer out of the way. Let's see here. Not that one, this one. Put the bearing block on, seat all of those, and then we're just going to pick up this stepper motor and align it so we can get all these started. We've got a little bit of play and a little extra length in there, so we can just get these all zipped on slightly. Now that they're all started, set it back down. Bring these all up snug. Kind of got to do them I'm doing them in a cross pattern to make sure that everything comes up and stays snug and square. They don't have to be crazy tight. They just have to be snug because they're going into plastic, so they will crush the plastic if you're not careful. So what'd you end up with Leo? I'm curious about your new part cooling design. Have you posted it to the group or anything? What's up, Duo? It's not done yet. How you doing, man? Spending as much time talking to chat as I am building the printer, so slowing things down a little bit, but it's totally worth it because the chat's awesome. So we need to push this rail that direction. Oh, okay, cool. Which one did you try? I've been curious about playing with other part cooling designs. Nice, you finally almost fully moved into your new place, dude? So we'll slide this way, and then should be able to have enough room to get that third bearing block and stepper in there. So all the electronics mount on this side. So I'm kind of orienting all the plugs and stuff like that so that they are oriented so that they can run up here nice and cleanly. Hey, at least you can get a decent night's sleep now with a bed again. That's one of the best things about moving in a new place is the first time you've got a bed. I'll have to check that one out, Leo, because that seems like something I will definitely play with. I'm going to be doing a bunch of different things with this printer, so it's by no means a one-trick pony. Going to be doing all kinds of stuff. Everything from lighting and lighting control and video and time lapse and you name it. I got lots of plans. Wow, still got 50 people in here. Holy smokes. You guys are awesome. All right. All those are in. Now, I suppose the next step is we mount. So these are the brackets that run up and down on the Z-rail. And we can start mounting those at this point. And then once we have that done, as we break stuff, at least they're aluminum, can't break, they don't really break that easy. So I think we need, what do we need? We need 10s, probably 10s. Yeah, it looks like 10s. So we got 6 10s per aluminum mount. That's 3, 4, 5, 6. And since we can, 4, 5, 6 washers. So just throw 6 washers on these and then put those all in. So I think that I read somewhere that you can control RGB strip from the Duo. So I think what I will be doing is taking my side panels off and putting white vinyl on the insides, except for the bottom, because the bottom looks awesome. But I'll be doing white vinyl on the inside to reflect light. And then once I've got it reflecting light, I'm going to put RGB strip in here. So when it's printing, it can be white. If it's heating, it can be red. When it's done printing, it turns green, that kind of thing. So, yeah. So I've been talking to 713 about having him whip me up a batch of all aluminum side panels. You gonna do an aluminum bottom panel with the milling, all the millwork in it too? That's gonna be part of that, right? Cause YOLO. So it doesn't look like you can use washers on these because I think they will hit. Well, that's a bummer. I like washers on aluminum parts. Oh well. Let's see here. Oh, hold on. You can use them because you only use 2 or 4 screws, not 6. So upper, lower, upper, lower. Yeah, the HDPE is more than enough, but it kind of falls back into that category of if you can, why not, other than cost. I mean, I'm sure that all these aluminum panels are going to be not cheap. Those are not long enough. I thought I grabbed 10s, not 8s. I must have grabbed 8s. Doggone it. I did grab 8s. That one's a 10. I grabbed mostly 8s though. I stream a little bit randomly because of my work schedule. I am trying to stream more often. I'm going to try and stream at least weekly, preferably more than once a week. Usually on the weekends, the streams are longer. In the weekdays, the streams are a little shorter, just due to the fact that, you know, real life and work and all that stuff. Yeah, the HDPE is pretty affordable. I'm glad you find the stream entertaining, and you're always welcome to come back and hang out some more. I do all kinds of other stuff, not just printing stuff. I do a lot of stuff with lithium-ion batteries and things like that. So one of my next projects coming up is I scrounged up a failed, what do you call it? A failed UPS. And I want to do a lithium battery conversion on the UPS over to from lead acid to lithium, and I've got the controller, charge controller, and all the things to do that. So that's going to be on the short list of things. I've got probably to the tune of 600 or 700 18650 cells sitting around the house at this point. So one of these days the wife's going to be mad at me because we're going to burn the house down. But safety first. I've only had one battery fire in the house so far, right there. But doing that stuff attended is really important. Kat will even attest that I don't leave those batteries unattended. Even when we have things to do, I'm like, I need 20 more minutes to finish this battery thing before we can leave.
Yes, and it's annoying, but smart.
Yeah, because had this happened unattended, we wouldn't be doing this today because the house would have burnt down. So, better safe than sorry by a long shot. Yeah, I'm super excited about the lithium UPS mod. That happened the other day on trash day because I was driving down the road and I'm like, that trash bag looks remarkably like a APC. And sure enough, it's one of the tan APCs. I have a 7-cell charge controller sitting right here on the shelf. So 7-cell little BMS. I'm hoping that 20 amps is enough output to run the APC. I don't think it's very big. I think it's only 1000 VA. So hopefully 20 amp is enough. I think it will be, but I'm not 100% on that. All right, now so the state of batteries are most dangerous at a couple of times. They're most dangerous when charging, I think, is probably the top time batteries fail, unless you're discharging them at extremely high rates. Then they have a tendency to fail then as well. Anytime they're under strain, and charging is a high strain time, discharging at high rates is a high strain time. So these are some of the battery packs I'm working on building. So these are large matched cell packs, and I have there's 3 of these bricks, plus I have bricks and bricks of these as well. So these are 10 cells in series and 2 cells in parallel. These are all going to go into an e-bike that I'm working on. Yeah, so lithium batteries are most likely to fail during charge or heavy discharge. They're also, and in particular during overcharge. So, yeah, what Duo just said, if you're discharging them at their max capacity for discharge or even more than that is when they're most likely to fail. Or if you're charging them at more than 1C, and 1C is denoted as their capacity in charge current. So if you have a 2000 milliamp hour battery, it's also, because of decimal points, you just move it in 3, it's a 2 amp hour battery. So a 1C charge on a 2000 milliamp hour battery would be a 2 amp charge. So you don't want to exceed that. I typically charge it less than that. You can get away charging faster on stuff like drone batteries, batteries really designed for higher charge rates. But so these batteries here, this is why this build has taken forever, by the way. Not that I mind. So like these drone batteries for RC drones, these are 45C, so they're safe to discharge at 1,550 milliamps times 45 at its maximum discharge rate. And I believe that these batteries are a 3C charge, so you could charge safely at 3 times this number. I typically only charge at 1C anyway. It's better for the batteries. They last longer. They're relatively expensive, so I just do that to make sure that I keep the batteries as healthy as possible. They do like to light on fire. These soft cell packs are much more dangerous from a fire hazard perspective than the 18650s, the metal cells. They come in very large capacities. So this is a 16 amp hour or 16,000 milliamp hour 6 cell, so 22.2 volts at 16 amp hours. This is a really big pack. We use these on for doing some lighting stuff on large drones. So C is a calculation. So yeah, C is a calculation. It's capacity. 1C is its capacity over for an hour. So a 16,000 milliamp hour battery is a 16 amp hour battery. So 1C would be 16 amps. Oh, yeah. It's not too obnoxious. There's a ton of light in this room. So, okay. I know from Jerry's videos, you guys people like room tours. So I'll do a really quick room tour here. Here's the lighting rig that's holding up the other camera for the down view. Here is the streaming and editing rig. Light panel. Over there is a trinocular microscope for doing surface mount electronics. Miscellaneous bench stuff. This here is the Ultimaker 3 Extended. Down here that I showed earlier behind the chair is a CR10 S4, so that's 400 millimeters cubed. It's highly modified at this point. Let's see here, toolbox, more lighting here, more lighting over here, lots of lighting all over the place. So much like Jerry, the Rode NT1 mic and a mixer board, good stuff there. So it's not too bad. These are all LED panels, so they're not nearly as much heat as they would be if they were other methods, but it still can get toasty in here. This might be a little harder to show. So this is my shelf o random stuff. So let's see here. Flip the screen around on the camera. Batteries. This is all 3D printing stuff and some camera equipment. Random boxes and a dog toy. Computer parts for my latest computer build. Lenses, more batteries and stuff like that. Soldering irons. Miscellaneous things like that. This shelf over here is all drone stuff. This is parts. This down here is the power supply and print bed and Z-lead screws for the 3D printer, and then a bunch more miscellaneous stuff in the drawers. So quick room tour, nothing special. If it's really a bunch of interest, we can do a more in-depth room tour at a later date. So the RGB strip behind the desk is adjustable and just kind of cycles slowly. So need a lead screw. So these are backlash. These remove backlash. So there's a little bit of play in this rod. So what they do is they use this spring and these two guides, and you squish them together and you thread them. And what that does is it basically takes up all the backlash, that slop when you go from one direction to the other. Basically what we need to do is squish it together. It's kind of a pain in the butt, but thread it together like this. I'll show this a little closer. Thread it together like this, and then once, see how it's kind of poking through, you got to back it out till it's not started, and then squish this one into that one, and then you'll see see how it's split just slightly. You can see like one thread, and then you can thread it through the rest of the way. And what that does is it means that it's actually, no matter which direction you turn it, it's actually still tight instead of having a little bit of slop. Like if you wiggle a bolt on a screw, it's got a little bit of play in it. This takes that out, and they call that backlash. They use this kind of technology in mills and lathes and any kind of precision stuff where you need that slop to not exist. Point the camera at the door behind me? Why am I doing that? Oh, I read the rest of your message. Okay, so this might get obnoxious. Hold on, let's find out. All right, see this? This is the Great Dane equivalent of a duck call. Ow. You're a good boy. Thank you for defending me from the pig. That's Bjorn. Bjorn is Norse for bear, which no one really understood why we wanted to name him Bjorn when he was this big and 8 pounds. But he's now 180 pounds of giant dingus. And people get it now. All right, so we are gonna slide this over, and we're gonna slide it over and realize that it's put together wrong. Doggone it. Okay. That's nice. So this bracket's on backwards. I'm going to have to pull it apart and flip it over, which means that I'm also going to have to pull this one apart and flip it over. So no big deal. Not hard, just takes a minute. Well, that's slightly annoying, and also my fault. I assembled it wrong. Easy to do when you got this many pieces all going at once. Not that. I need the nut driver wherever it went. Arrgh. Yeah, he's pretty funny. He's a good boy. He's a pretty damn good dog. Obnoxious and good for what, we're not sure, but he's good. Man, I'm losing all kinds of stuff today. What the heck? There is a nut driver around here somewhere. There it is, hiding underneath the muffin tin. All right. So, I think the easiest way to do this will be to pull this linear rail or linear slide off. So here's a fun fact about linear slides. They like to have all the ball bearings fall out. So let me see if I can get a shot of this. I'm going to switch over to the other camera. All right. So this is a block that holds all the bearings in if you have to slide them off the rail. So we're just going to slide this gently. Oh, it's still stuck. Okay. So next thing we're going to do is take this off because it hits and it's in the way. So we're going to take this off. All right, now that that's off, now I should be able to slide this bearing out. So we slide it onto this plastic piece to keep all the bearings in, all little ball bearings in. And if we're careful, you can see them in there, all those little ball bearings. If you drop this little plastic piece out, all of them fall out there. I think there's 52 in each one of these slides. So now that that's done, now I'm going to take these off. They do not have the capture bar. These are made by a company called, I believe, Ziltech. They are not high winds. Yeah, these are Ziltechs. The kits, the Ziltechs and the kits are all coming pre-disassembled, cleaned, and tested for smoothness. As far as I know, nobody's had any issues with them. They're good rails, but they're about a quarter the price. Normally I do tape them, but I needed to actually take it off the rail. So for right now, I've just got it set aside. So if you'll notice, these two on this side are taped. So they have that's done. But yeah, these do not have the bar that locks them from coming off. So I'm going to take all of these nuts loose. And then I'm going to loosen these ones right here so that I can slide it inside that top rail. or inside that side rail. And once I can slide it down, then I can pick this up and flip it over, and it should save me from having to disassemble the whole rail. So now I should be able to slide that down and slide this whole rail up and out, and then flip this over. And I will have to adjust these screws, or these bolts, get them lined up and in. Sorry, the other camera can't really see what I'm doing. It's real finicky. I'm just going to lock this down so it stops trying to fall. There we go. So I'm going to poke my head in here and try and line these up. There are tweezers right there. So this is fiddly at best. And it's going to be easier if I just loosen these. That way I can put them up straight. Much easier. So then we do the same thing on the bottom here, which you guys are going to have a hard time seeing because it's at the bottom. Loosen that, let it drop down, line all these up. Woohoo! Auxiliary's awesome. We will go raid him as soon as the raid's over. I'm going to finish mounting this one rail, and then I think we're probably done for the night. It's almost 9 o'clock, and I have to work in the morning. So I think we will do that. Get this last rail mounted, and then we'll go raid Auxiliary because he's awesome. All right, so that one's in. Now I should be able to just throw these on there. I was hoping to have one of these lead screws put together before the end of this day, but some dummy put it together wrong. So it's what it is. Almost out of space. Can't quite get that one. That's right. Good. It's close. There we go. All right, and just so that we don't drop the bearings out of this thing accidentally, we're going to slide this rail, or this slide back onto the rail. And I'm going to move the camera up so you can watch that, just in case I throw it on the ground. So we just slide this gently back onto the rail, and that piece falls out, and now the rail's nice and smooth. They're not lubricated right now so that they don't get grease all over me, and then when I'm done I'll lubricate everything. And wherever my tape went, just to make sure that they don't go anywhere, tape it just like that so it can't slide. And tighten this down here. There we go. Okay, those are nice and tight. That's got some slop in it. Now peel this off, and I'll retape it in a minute here once these are all screwed in. Actually, once these are screwed in, it won't matter, so I'll be able to leave that off. So now I can mount this there, that one there. And just to make sure everything's square, I'm kind of holding it tight against this edge to keep all the screws lined up. Snug. Do this here again in a cross pattern. Hard for you guys to see. So I'm doing this in a cross pattern. So I started here, and then I did here, and I'm going to do here. It doesn't have to be crazy tight, just snug. And then here, so that you don't tear the threads out of the slides. Then we drop this Z-rod. See you later, man. It was great having you in. I will get the lead screws in the bed for sure next stream. So move that down there, get this in here. So that's where the lead screws go. And then a couple of 8mm. Yeah, the top camera focus is not great. It's a Logitech Brio, and it's just limited. It doesn't have any real focusing capability beyond auto. The camera over here, the main camera, is much better. We'll go back to that. This camera is much better, but kind of hard to show you what's going on some of this stuff. But much higher image quality. The lag in the stream is real. There we go. See if we can get all the way in. But half the time I block what's going on. Right, I need more Z-screw. Come on, focus on my hand. Yeah, it's just, so the problem is this thing is so tall that if I take it off autofocus, something is always out of focus. And if I leave it on autofocus, it's always trying to focus on random things. So there's just really no good solution for this thing. Right now, I'm running the lead screw, or running this backlash nut for this lead screw. Focus. There you go. I'm running this up the screw to be able to get some more slack so that I can get the driver in here with enough room to be able to put the screws in. Actually, you know what might be easier? If I take these back out, I think I can mount it to the Z and then mount it to the slide. I think that will be easier. So pull this down a little bit so you guys can see what's going on. Now I'm going to bring this in here. And then I've got, I think those are 8s, so I'm going to need 10s. Those are 10mm instead of 8mm. And I still don't actually think that's going to be enough. I'm probably going to go to 12s. I think I have 12s in a bag. Those are 16s, 10s. I'm 3x12s. So these will give me enough extra length to get these backlash nuts nice and attached. Be easier once I get the first one started. Those might still be too short. I think I'm going to move up to the 16s because I don't think I have 14s. So what I want to make sure is that because these are threaded into plastic, I want to make sure I have as much thread as possible for those. So I'm just being really careful. The instructions say, and I should probably be looking at those, but so those are 16s, and they'll be plenty long enough. Make sure those go back in the right bin. Dang, 38 of you guys still watching. That's awesome. I appreciate you guys being here and hanging out with me for this. Once we finish this last attaching piece, we will go right to Auxiliary, who is a awesome game streamer, also known as Houston. He does computer builds and things like that. Yeah, I was thinking about that actually. I thought that might be a nice addition with the longer screw. My only concern is I think it might interfere with the spring. I'll have to double check. It's certainly overkill because there's actually very little force on this part. So it's overkill no matter what. But there is a little bit of thread sticking out of the top, but what I'm concerned is there's not enough gap between, let's focus, between these threads, this bolt and this spring, so I don't want to pinch the spring. Hey, what's up, Onion Man? How you doing? We're putting together the Z leads. So all that spring is doing on this part is it's taking up, so these are two separate pieces. Why that spring is there is to make those two pieces push apart and take up any slack inside the threads between the threading on this plastic part and the threading on the rod. So it basically pushes against. I just don't want to pinch it because I don't want to damage it. I'd rather have it intact. Would it matter? Probably not. But rather than damage it, I just want to like leave the. If the bolt doesn't fit, if I can't screw the bolt on cleanly, I'll leave it off because it doesn't hurt any. It's not intended to be there necessarily, so it won't hurt anything to not have it. There's almost no real stress on this part. Focus. There we go. There's no stress, no real stress on this part. Yeah, but the bed's not real heavy. I mean, it's kind of heavy, but it's 12 screws. One of these screws is enough to hold that bed up. So but we'll kind of see how it shakes out. If I can get a nut on it, I definitely will. If it doesn't fit cleanly, I'll leave it off. Yes, the top camera is mirrored at the moment because of the way I kind of spin it around in all different directions. It depends on what I'm looking at. Like if I were looking over here, I would spin it around and then it's mirrored the other direction. All right, that seems reasonably good. Let's see if we can get a nut on it. No, you can't get a nut on it. It won't turn. The screw is too close to the plastic, so you can't actually, the edge of the nut gets in the way. So you can't actually get a nut on it. But that's okay. It's totally not needed. So we'll drop this in there. Then we'll slide that up to where that needs to go. And then we'll put these in. Gonna have to slide this over so that it fits. Yeah, those Delrin Z nuts are real tough. Like it would take a lot of work to get those out. There's no real need. So the spring on the Z, all that does is take the backlash out of the lead screw. So no big deal. It's not really doing a whole lot. And you guys probably can't see what I'm doing now that I'm zoomed in so far. There we go. And tilt that up just a smidge. Perfect. Hopefully I can do this without getting in the way. There would be backlash because of the mismatch in thread pitch or in thread size to the thread size on the dowel end. So what this does is it basically means that it lets the nut that runs up and down on the Z expand slightly to take up that backlash. There's always a little bit in machining. That's why basically every precision machining tool on the planet has anti-backlash features of some sort. Consumer grade machining stuff, not so much maybe, but like anything 713's got, all of his stuff that has lead screws all has anti-backlash in it. Most of his are going to be either automatic or manually adjustable too. I think that's correct anyway. So next thing I'm going to do is I'm going to leave this so that it can slide a little bit, so that once I've got all the Z's that I can run it to the bottom and tighten it down, and then run it to the top and tighten it down. Yeah, they're all on ball screws. And all yours are going to be adjustable and things like that to take out as much of that backlash as you can get out of there, because that stuff is the enemy. So spin that around. Once that's seated in the yeah, all of those kind of feed mechanisms are going to have that anti-backlash in them of in some sort of iteration. So tighten this lead screw down inside the coupler, and that's permanent now, or relatively permanent. So that's one. 2 more to go, and we will pick that up at a later date. Let's go see what auxiliary is doing real quick. Let's go see what he's up to. All right. So it looks like he is playing PC Building Simulator. So let's queue up for raid on him. Auxiliary's awesome. We'll go raid him. All right, here we go, guys. Wait, how do I not have permission to perform that action? Oh, it's because I'm on his channel. Duh. All right, here we go. Appreciate you guys coming and hanging out. If you haven't followed, feel free to do so. I'm under the same name everywhere else. Feel free to come and join us for more tech-related live streams at least a couple times a week. Talk to you later, guys, and here we go. I appreciate the follow. Thank you very much. And click and raid now. Talk to you later, guys. Thank you for the fun evening, and we'll see you next time.
Oh my goodness. Holy cow. Oh. It's happening. It's happening. Hey, how's it going, man? Woo. How you